Greetings everybody, I'm Dipankar Nanda, currently in VSSUT Burla, doing third year in electrical engineering. Okay, so today I am going to share an idea, okay, an idea or an analogy, okay, which I came across recently. No, it was about maxima and minima, right? You must remember while you were in your intermediate, or you are still, or you are going to be in your intermediate, okay, you will read this subject of application of derivatives, okay. One of the application of derivatives is to find the maxima and minima, okay. How you should know it, or you will know it gradually. I'll assume that you know it, right? So we basically did the second derivative test, okay. We find the first derivative, equate it to 0. We equated the first derivative to 0. Then we found the null point, the maxima and the minima, those collection of points, okay. Then in order to sort out, to check whether the point is a maxima or a minima, we had to do the second derivative test, okay. Then if the second derivative test were positive, it is a minima. If it were negative, it was a maxima, okay. You must know it. But the question is, why does this happen? Sorry, the question is not why does this happen. The question is how do we know, okay. I mean, how do we say that, okay, if the second derivative is positive, so we get minima, or the opposite, okay. Why do we say that? Do we ever think about it? Because I frankly never thought about it. I just remembered it, like I just remembered it, okay, like it was no, just okay, उल्टा होता है. क्या उल्टा होता है कि जब second derivative positive होता है तो minima उल्टा, जब positive होता है तो minima, जब negative होता है तो maxima. So I remembered it like that, but that was okay, that was fine, did that work? But the thing is, you have to think, what does this happen? Okay. So actually what happens, what is you should know what is the significance, the physical significance of derivatives, okay. Derivatives is nothing but the rate of change of something with respect to something, okay, or rate of change, or the slope of a tangent of a function at a particular point, okay. That's a derivative. Now what is second derivative? Second derivative is the rate of change of slope of the tangents of the function at points, okay, at given points, or at as we go, you know, in a period, okay, or in a neighborhood. So that is what, now the change of the slopes of the tangents of the function, right? So it's quite complicated when you think, when you draw it, and when you see it, okay, you draw tangents tangents to the curve of a function, okay, to the graph, or to the not to the graph of a function, and you write down the slopes, and you check how do the slopes vary as we go from left to right, okay. How does it vary, okay, if it increases or if it decreases, okay. We know that what we know that, okay, when we get a maxima, like for example in a sinusoid, when there is a maxima which is at 1, at sine 90 it's 1, we know that at maxima the slope of the tangent is 0, okay. We get a flat line parallel to x-axis, right? The slope is 0. So that's the common notion. If we have a maxima or we have a minima, the slope is 0. We get a flat line which is parallel to the x-axis, right? That's there. But I am going to make an analogy of how to, you know, understand this. No, I will give you a physical, you know, description of how does this actually happen. So what happens is, imagine, okay, visualize this, okay, close your eyes and visualize that you are going in a sinusoidal hill. Okay, you're going on a sinusoidal hill, like it goes like this, okay, like a sinusoid basically, and you are at the point 0, okay, you are at the origin, okay. So what happens when you are in the vehicle and you start driving towards the, you know, first crest, okay. So when you're going up when you're approaching towards the crest, what happens to your speed? It decreases, right? When you go up, your speed decreases. So we say that, okay, you're retarding. you're retarding or the acceleration is negative, right? Because your speed is decreasing, right? So acceleration is negative when you go up, when you reach the crest, okay, when you're approaching the crest or the maxima, right? What happens when you go downhill? When you are approaching, when you're going down the sinusoid, reaching the minima point, okay, the -1 point, what happens? What happens is your speed obviously it gradually increases. It increases so fastly, like you are unable to control your vehicle. The braking gets difficult. Okay, so your speed increases. So what about the acceleration? The acceleration is positive, right? When your speed increases, we say that okay, that your acceleration is positive. Got it? So you remembered? So when you're going up, your acceleration was negative, and when you're coming down, your acceleration was positive. Okay, so that's it. So what was I trying to say? That acceleration is what? Well, it's just a second derivative of the position. Okay, it's the second derivative of the position with respect to time, right? And speed is the first derivative of your position with respect to time. So right, so acceleration or the second derivative was negative at the crest, at the maxima point, right? And acceleration or the second derivative was minima. Acceleration of the second derivative was negative at the minima point, right? That is what I was trying to say. Okay, so I hope you visualize this. You visualize this very clearly, and you like this idea. And okay, the thing is, we don't visualize it. We don't visualize things. It's very important to visualize maths, especially maths, right? Okay, that's it for me. That's it from me today. And thank you. I hope you understood this. Okay, have a good day. Thank you.